Hi everybody, if we have a triangle here and we draw three lines from three different vertices of this triangle on its base such that they all meet at a particular point such that the area of this triangle is 40 and area of this triangle is 72 and area of this triangle be 84. Then we need to find all the remaining areas like this and this. Let's call them x, y and z. So what we need to do is just find area of region x, y and z. So first you please give your trial to this question and keep watching for the solution. So for finding our answer we need to learn some theorems, and one of them theorems says if we have a triangle ABC and we draw three lines from in their three different vertices such that they meet at a particular point like this, and we also name them all. So this theorem says if CD divided by DB times DF divided by AF times AE divided by EC is equals to 1, and this theorem is known as Keva's theorem. And the second theorem says if we have a triangle ABC and we extend BC at E and from E at an angle we drop a line on AB which intersect AB at D and AC at F. So this theorem says AD divided by DB times BE divided by CE times CF divided by FA is also equals to 1, and this theorem is known as Menelaus theorem. So we use these two theorems for finding our answer. Now here is our figure. Now we name the sides. Let's call this side BA, this BB and this BC, and call this side BD, this side BE and our last side BF. And we use a pedagogy for finding our answer, which is if we have a triangle ABC and we drop a line from point A to the CB which intersects CB at D. So the both triangles shares a common altitude. Let's call this altitude be capital H. So area of triangle ADC is equals to half times CB which is base times altitude which is capital H. Similarly, area of triangle ADB is equals to 1 over 2 times DB which is base times altitude which is capital S also in this case here. Now we divide these both areas. So what we have is area of triangle ADC divided by area of triangle ADB is equals to this all stuff. So this is equals to CD divided by DB. So now using this pedagogy we can easily convert ratio of areas in the form of ratio of their subbases. Now using Keva's theorem in our figure, so we have A divided by B times C divided by D times E divided by F is equals to 1, and using this pedagogy for converting our sides into areas, so we have A divided by B is equals to 40 divided by 72. Similarly, C divided by D we have 84 divided by X. Similarly, E divided by F is equals to Y divided by Z which is equals to 1. So we can convert our ratio of sides into the form of area of triangle, and please remember this, we use this later. Now let's call this side be gray line and this side be red line, and using Menelaus theorem in our this triangle, so we can say E divided by F times A plus B divided by B times gray line divided by red line is equals to 1. Now using the same pedagogy we can convert our side ratio of sides into the ratio of areas. So using our this triangle we can say E divided by F is equals to Y divided by Z, and using our this triangle we can say A plus B divided by B is equals to 112 divided by 72, and using our this triangle we can say gray line divided by red line is equals to 72 divided by 84 plus X which is equals to 1. Now again we convert our ratio of sides into the form of ratio of areas. Now this stuff we find by the Keva's theorem and this stuff by Menela's theorem. Now we can express this as this, so we can use this value at here. So what we have got is this, and doing furthermore simplifications, we have got x is equal. Now looking in this triangle, so we have 40 divided by 72 is equals to a divided by b, and looking in our this whole triangle, we can say 40 plus z plus y divided by 72 plus 84 plus x, which is 60, is equals to a divided by b. So fusing these more two equations, so we have this, and we put x is equals to 60 that we found previously, so we have this, and using this value of y divided by z, so we have y divided by z is equals to this. So relating these both equations, and after relating these both equations, we have got y is equals to 45 and z is equals to 35. So finally we have x is equals to 60, y is equals to 45 and z is equals to 35, and that is our correct answer.